Bill Nye the Science Guy.
Bill
Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
This episode is brought to you by Indicators, making your world a more informed place.
So, what is an indicator?
I don't know.
First, we have to explain acids and bases. Now, you may be thinking that you could only see acids and bases in a chemistry lab, but you're wrong. Have you ever drank Coca-Cola
That's actually pretty good.
or taken a bite of an orange? How about eating an excellent cake with baking soda? Well, those are acids and bases too.
Acids tend to taste very sour, while bases are slippery, like picking up a wet bar of soap. In simple terms, an acid has a very high concentration of hydrogen ions. Bases have a low concentration of hydrogen ions and a high concentration of hydroxide ions. So, where did these ions come from? The answer is
Water. Yep. Just like this pool. Oh,
To sum it up, we're going to head on over to Soundtrack of Science as Not That Bad Records just dropped their new mixtape.
Cause you know I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, no acid. I'm all about that bass, bass. Yeah, it's pretty clear, I ain't no science fool. So you got litmus, well I can turn it blue. Make it go boom boom all over the place. When all the H plus meet all the OHs. Pink phenolphthalein, I think that's straight dope. Mix in a lipid here and it'll make it soap. You want it neutral, pH is low. Better set up a titration with a strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. If an acid gets in them, we just have to neutralize. That neutral, stack that neutral. Know I love me, my stomach, and all the things it dissolves.
Consider the following. You're building a puzzle and you have two pieces, and you put them together and you essentially have one piece. Then you can take this one piece and break it up into two pieces. The same thing happens with water. It starts with a liquid. This water then spontaneously generates hydrogen atoms.
Spontaneous. Yeah, it's a big word. It basically means something happens without an outside driving force. Kind of like me doing a cartwheel mid-sentence.
So this water breaks down into H plus and OH minus ions.
Over here and over there. Water everywhere. Water in the pool.
This process is called autoionization.
Help the seeds grow. Sailing on the water, cruising on a boat. Let the water.
To rank solutions on their concentration of H plus values, a pH is taken. This is the negative log of the concentration of H plus ions.
If the pH is less than 7, the concentration of hydrogen ions is very high and the solution is acidic. If the pH is 7, which is common in water, the concentration of H plus is equal to the concentration of OH minus, and the solution is neutral. If the pH is greater than 7, The H plus concentration is very low and the solution is basic.
Now, finding the pH is not always so easy. This is where indicators come in handy. An indicator is any substance that gives a visible sign, usually by a color change, in the presence or absence of a threshold concentration of chemical species. That may sound daunting, but they are very helpful. Did you know that indicators are used to keep pools at a certain pH? Let's look more into this.
There's nothing more relaxing than taking a quick dip on a nice hot day. But if you're maintaining the pool, you have to make sure you keep the pH at a certain level to not irritate anyone in the pool.
To keep the perfect, slightly basic pH, around a 7.4 on the pH scale, indicators are used.
The indicator testing the pool water is a liquid and is usually added directly to solutions, while the paper form is often dipped into solutions and then removed for comparison against a color pH key. pH indicators are also come in varying sensitivities. Some may change color over a wide range of pH levels, like the phenol red, the indicator used to treat the water, while others only change a single color when in contact with specific pH such as phenolphthalein, which is used for titrations. Now, pH indicators work by detecting the amount of hydroxide or hydrogen ions in a solution. They do this by reacting with the hydrogen and hydroxide ions as they themselves are weak acids and bases. The indicator reacting with the pool water, phenol red, is a weak acid, as it reacts with its conjugate base, the water, the hydrogen ions, within the dissociate, and their concentration in the solution determine the color that we see. The same applies for weak base indicators. So when we add 5 drops of phenol red to the pool water, the light pink color you view is determined upon the ratio of hydrogen ions to hydroxide ions in the solution.
The color of this solution is a light pink that falls between 7.6 and 7.8 on the pH scale. This is slightly basic for the pool water, which should be around a 7.4 on the pH scale. If the solution was a darker shade of pink, we would know that it has too high of a concentration of hydroxide ions and is too basic to swim in. If it was a shade of yellow, we would know that there is too high of a concentration of hydrogen ions and is too acidic to swim in. The water being more basic could be due to a chlorine stabilizer or HTH granular that was added to the pool, which makes a basic solution. Overall, this indicator ensures that you'll have an irritation-free day at the pool.
pH indicator charts are used to determine what indicator will be the most helpful. With the pool water, phenol red was the best indicator to use as it had a color change within the range of 7.4 to 7.8, which is the desired pH. This is not always the case. The chart shows certain indicators and when the color change. Before performing the experiment, one should look for their desired pH, find which chemical has a drastic color change at that pH, and add it to their solution to record when the experiment is over. This is why phenolphthalein is often used in titrations. It has a bright pink color change slightly after 7, so when enough acid and base are combined, there should be a faint pink color suggesting when the pH is neutral.
But you don't need to go to the lab to find these indicators. You can make them at home with something you may or may not already have, depending on how healthy you are. For our try this, you'll need a couple of glasses, a blender, coffee filters, and a funnel, along with some ingredients from your pantry or fridge, like a red cabbage.
You smell like cabbage, yes you do. You smell like cabbage and you know it's true. I don't know how many times I've got to tell you. You smell like cabbage. You smell like cabbage on a rainy day. You smell like cabbage whether or not. I don't know how many times I've got to tell you. You smell like cabbage.
And from the pantry you will need baking soda, vinegar, and distilled water.
Also, from the fridge, make sure to grab a lemon.
And when it comes to safety, you will need goggles and aprons. To start the experiment, you will need to add 4 cups of warm distilled water to a blender.
2 cabbage leaves.
To blend, make sure to hold down the lid and give the blender a few pulses.
In order to prevent any small pieces or stragglers from your cabbage smoothie, in the indicator, pour it through a coffee filter in a funnel. Mmm. Yum.
And finally, take your filtered cabbage solution and pour it into several different glasses.
And while you're pouring, make sure to leave room for the other solutions going in the glasses.
Then, take one of your remaining ingredients and pour it into the cup with the homemade indicator. This one is baking soda.
Every time I read your message, I wish I wasn't one of your exes. No, I'm the fool. Since you've been gone, been dancing on my own. These boys up in my zone, but they can't turn me on. 'Cause baby, you're the only one I'm coming for. I can't take no more, no more, no more. I wanna but I'm broken hearted. But I like to party, touch, but I got nobody here on my own. I wanna but I'm broken hearted. Since the day we parted, touch, but I got nobody, so I do it so low. Every single night I lose it. I can't even hear the music without you. Oh yeah. Try to stop myself from calling, but I really wanna know if you're with someone new. Since you've been gone, I've been dancing on my own. This boy's up in my zone, but they can't turn me on. 'Cause baby,
Now let's take a closer look at the experiment. The molecule within the red cabbage that is responsible for its color is a pigment a part of a group of pigments called anthocyanins. Anthocyanins give off a purplish color and are responsible for the color of many of our foods, such as blueberries and even red wine. The anthocyanin present in red cabbage is called cyanuclin, and it gains hydroxide ions at a basic pH and lose them at an acidic one. This seemingly minor change in the molecule is sufficient to alter the wavelengths of light reflected by the compound. So, the color changes as the pH does. When acid is added to our red cabbage solution, the increase of hydrogen molecules cause the cyanuclin to change shape that make it reflect red wavelengths. When a base is added, there is instead a high amount of hydroxide ions.
These make the shape of the indicator one that reflects a green or yellow light.
Remember that pH scale we drew earlier? Water is a neutral solution, so it has a pH of around 7, meaning that the concentration of hydrogen and hydroxide ions in the water are similar. This does not apply for the lemon juice and vinegar, which each have a pH of 2.0 and 2.2 respectively, so they are considered acids as they have pHs that are lower than 7, while the baking soda solution and window cleaner are basic. The baking soda solution has a pH of about 9 and the window cleaner has a pH of 10.
These numbers are reflective of the colors shown. Using the red cabbage as an indicator, the most acidic color is the bright pink, as seen in the lemon juice and vinegar sample. Then, as solutions become more neutral, they turn more purple. This is why the tap water had a bluish purple tint. Then, the baking soda solution created a strong, dark blue color which represents its pH of 9 very well. The most basic solution was the window cleaners, as it is seen this way with the teal color it produced, as some green was mixing with the blue.
The anthocyanin in the red cabbage makes that home indicator very successful. So on your next rainy day, where taking the pH of the pool is not as enjoyable, stay in and create your own indicator.
I don't know how many times I got to tell you, you smell like cabbage. Sometimes you smell like a banana.